Hi, I'm Pat Prokop, and I recently gave a program about my heavenly backyard astronomy over at the Armstrong Center. And a lot of you said you wanted to make it there, but you just couldn't get there at that time. And asked if I could put this video together so you could see it. So that's what I'm doing right now. Now, I live in the city of Savannah, and I do have city light pollution ongoing in my area. Now, I do use filters on the scope that help reduce the amount of light pollution and bring out the nebulosity up in the targets up in the sky. But to me, it's just amazing, literally amazing at what's available up in the sky near you. So let's take a look and let's enjoy the heavenly backyard astronomy. Welcome to Heavenly Backyard Astronomy. This is the program I presented at the Armstrong Center a couple of nights ago, and I want more people to be able to see it that asked to see the program, but they were not available to come that night. So I'm putting it together just for you. This is the telescope that I use. This is the main telescope. It's a Celestron 11-inch Edge HD telescope, which is a f10 aperture. I can reduce it to f7 or even f2. But it's really good for planetary observation and for distant galaxies. And notice that it's on an equatorial mount, and this keeps it tracking with the rotation of the Earth, so it tracks on the stars or the galaxies and stays locked as the Earth rotates below the telescope. This is another one. This is the ED80T telescope. Excellent telescope, little 3-inch scope, but it does a fantastic job. It's a refractor type telescope as compared to the Celestron, which is a Schmidt-Cassegrain type telescope. And then the third telescope I use is this one. It's a Maksoutov-Newtonian telescope. It has a mirror back in here. It has a corrective lens on the front, and then the light goes into the back of the mirror, reflects off the secondary mirror and up into the eyepiece, in this case the camera, which is right here, which is an Altair one-shot color camera. And another view of the camera attached directly to the telescope, the Altair Hypercam 294C, which is a one-shot color, and it's cooled, so I can cool it down to give you better pictures from the processing. Meanwhile, heavenly backyard garden in my area, my backyard, where the telescopes are located. And the garden, when in full bloom, looks something like this. So during the day, I have the gardens to enjoy, and at night, I have the astronomical gardens to view. So speaking of that, let's take a look at some of the views from heavenly backyard. Now, first of all, terms that we have to know about: distance, light year. What is a light year? Well, the answer is this. 1 light year is a unit of astronomical distance, which is equivalent to the distance that light travels in 1 year, which is 5,875,549,728,000 miles, or nearly 6 trillion miles. That's how long light takes to travel 1 year, the distance. And when I look at objects and I say the object is 2 light years away, or 5 light years away, or 100 light years away, or even 2 million light years away, we're talking about the distance that it took light to travel to get back to our eyes. And light's traveling at 186,200 miles per second. So that's a long distance. The first thing I want to talk about are nebulae. That's the plural for nebula. And a nebula is a cloud of interstellar gas and dust, such as dark emission and reflection nebula. Any celestial object that appears nebulous, hazy, or fuzzy, and extended in a telescopic view. So let's take a look at the most famous of all nebula, and that's the Orion Nebula. And a lot of times, if you look at it through a small telescope or binoculars, this is actually what you see. It looks like this. Most of these pictures you're going to see that I show are not what you actually see in a small telescope looking through the eyepiece, because their time exposure, some cases they could be up to 2-3 hours long. In this example here, this was only a couple of minutes. So this is a very prominent nebula that is visible up in the autumn and the winter skies. Here's another view using filters on my telescope and a little bit longer exposure time. And again, you can see the nebula. This is where new stars are being born. And here you have another nebula. It's called the Running Man Nebula. Looks like a little man running, doesn't it? Anyway, this is another nebula that I captured just a few months ago called the Eagle Nebula. This is prominent in the summer southern sky. And you can see there's a lot of stars in and around the foreground and the background of this nebula because it's in one of the arms of the Milky Way galaxy called the Sagittarius arm of the galaxy. This is the Messier object number 27, the Dumbbell Nebula. And there you can see I captured this a year ago, July 12th, and this is a 70-minute exposure. This is the remnants of a star that exploded. And this is the outgassing that is ongoing as the gases are moving outward away from the star itself, the central star, which exploded. Here's an area of new star formation. This is not an exploding star. This is a new star formation called the Rosette Nebula. And this is an emission type nebula, and another view of this is from the ED80T refractor telescope, and then from the Maksoutov-Newtonian telescope, look at this view of the Rosette Nebula. And this one, talking about light years now, 5,200 light years away. You think, wow, that's way out there. Well, actually, that's pretty close astronomically because that's in our galaxy. This is contained inside the Milky Way galaxy. The Triplet Nebula, some people pronounce it Triplet, but it's tri. It's three parts right here, 1, 2, and 3. That is a summertime object, and it's again an emission and reflection nebula, and again areas of new stars being born in this area here. The Cocoon Nebula. A lot of these nebulas in this shape or so forth are new star birth. And once again, these stars are all part of the arm of the Milky Way galaxy, the Sagittarius arm. Here's a closer view of the Cocoon Nebula. All this is up in the sky near you. Now, like this picture here is about an hour and a half, 2-hour exposure. This is the Ring Nebula. Now, this is a nebula where the star here exploded, and this is the outgassing of the gases from the explosion of the star itself. The star's life is over, and it's sending its material out into space for new stars to grab onto and form into other objects. This one is about other stars. This is about 2,000 light years away, formed from an older star that exploded. Now, a friend of mine, Walter Clayton, said, you know, if you look down in this area right in here, near the Ring Nebula, there is a galaxy. If you can find it, you can push your graphic program to see it, and I did. And this is the object here. It's a galaxy. It's called IC 1296. And to give you an idea how far away this one is, this is the farthest thing I have picked up in my telescopes. This is 240 million light years away. In other words, this is what the galaxy looked like 240 million years ago. I don't know what it looks like today, but there it is, and it's way out there. Just another thing that's possible to see. This is another star that exploded. As a matter of fact, the explosion produced a supernova, and it was viewed in China particularly and recorded by the Chinese astronomers back in the year 1054 AD. And it was so bright that it shined during the daytime sky. The Crab Nebula itself kind of looks like a crab if you really have a vivid imagination, about 6,400 light years away. This is an interesting nebula, the Owl Nebula, Messier number 97. This was formed from the outflow of materials from the stellar wind of the central star about 8,000 years ago. It's not 8,000 years old, but the gas cloud is about 8,000 years. And if you look closely, you might see something that looks like an owl, the face of an owl. Anyway, this is about 2,030 light years away. This is one of my favorite pictures. This is the Horsehead Nebula. I took this with the little telescope, that little 3-inch black telescope, the ED80. It's an amazing picture. This is not what it looks like when you look at it through the telescope. You can barely see it when you look through the telescope, but this is over a couple of hours actually exposure time to get this view here, a closer view of that. The red part here is the emission and reflection nebula. However, the Horsehead itself is comprised of obscuring stellar dusk. That right there produces what looks kind of like the head of a horse, hence the term the Horsehead Nebula. Fairly close, speaking, astronomically wise, 1,400 light years away. All right, so much for the nebula. So there's a lot more to be seen, but not today. Heavenly backyard planets. I've seen many of the planets through my backyard. Mercury is very difficult because it's so low in the sky and I have a lot of trees all in all directions. So I just can't get Mercury. And Neptune is so far away. It's nearly 2 billion miles away. I'm trying to get it. Hopefully I'll get a picture of it coming up soon. But these are the other planets I picked up in the backyard. And when you talk about planets, the first thing you got to talk about is, what is a planet? Well, it comes from the Greek meaning wanderer, a wandering star. You know, back in the early days, before the time of Christ even, the planets were thought to be gods because they moved among the background stars. And that to the astrologers and the high priests and the other kings and queens, this to them gave them special meaning, and they were termed as gods. So, but they're basically stars. As you can see, they look like stars, but they wander along with these background stars. They're moving. And nowadays, of course, we know they're planets that are orbiting the sun. One of the pictures I had a couple of years ago, actually last year, 2018, of the planet Mars. This was just before I started learning how to process the planets, and I'm getting better at it. So on my next term around for Mars, hopefully I'll get even a better picture. Mars is only visible like every other year. Right now it's in the phase where you can't hardly see it at all. So Saturn is everybody's favorite. It's the ring planet. And you can see it also has atmospheric striations like Jupiter, bands of fast-moving winds in the mid and upper layers of its atmosphere. And the rings itself have different portions of the ring. This is my best picture so far of Saturn right here, and you can see it's just a spectacular look. When you look at it through a small telescope, even a medium-sized telescope or binoculars, you can see the rings. It's not going to look like this, but it is really good. You know, you don't have to use astrophotography to look at Saturn or Jupiter. Jupiter, if you look at it, you can also see moons. Not in this picture here, but with a small telescope or binoculars even, you can see the 4 Galilean moons of Jupiter. But one of the most amazing things about Jupiter is this giant red spot. It's been ongoing for years and years, actually centuries and centuries. It's the giant red spot. It's kind of like a giant hurricane. What did I say? Giant? We're talking mega giant. How big is it? Well, this little area here, you can probably fit 2 Earths inside of it. Jupiter is a big planet. It's also known as mighty Jupiter or Thor. Venus, the cloud-veiled planet. Venus shows phases like the moon because it's an inner planet. It's between us and the sun, so it exhibits phases. And one of the things about Venus is when the scientists were measuring the new spacecrafts that were launched to probe into the Venusian atmosphere, one of the astronomers and climatologists was James Hansen of NASA, and he noticed that the temperature of Venus should be somewhere around 350 degrees, 325 degrees, due to its orbit and due to the clouds. But when they actually measured the actual temperature at the surface of Venus from the new spacecrafts, the values came out to be about 890 degrees. And they also found out the composition of this atmosphere was mostly carbon dioxide. About 98% of that atmosphere is carbon dioxide, a heat-trapping gas. The planet Uranus, I took this picture, it was 1.824 billion miles away. And you can even see some of the striations on the atmospheric winds that are flowing around the planet Uranus. And all right, moving along to clusters or globular clusters. A globular cluster is a large, compact spherical star cluster. Typically consists of old stars, and the old stars usually appear in yellow in color, but it could contain newer stars, and those usually are colored blue. And they're in the outer regions of a galaxy in most cases, as we will see. Now here's a globular cluster right here. This is what's called Messier number 22. Messier, George Messier was a astronomer back in the 1700s, and he was one of the first to have a medium to large type telescope, and he started cataloging a lot of these objects that were fuzzy and nebulous, and he wanted to make a map of the sky. So he cataloged these objects, and he came up with 110 of them, and these are known as Messier objects, or M22 for this example. This is about 80,000 stars. They're old. They're about 12 billion years old. The sun is about 4.3 billion. So to give you an idea that these are much older stars than the sun. And this is about 10,400 light years from Earth. Another globular cluster here, a smaller size containing about 20,000 stars. This is not in age of billions of years. This is the age of millions of years. So this star cluster here, these are brand new stars, baby stars, if you want to call them that, adolescents, much younger than our sun. And the distance here are 7,200 light years from the Earth. And you notice a lot of these star colors here are blue. Another star cluster, that's Messier number 10. 11.4 billion years, so there's another very, very old one. 14,300 light years from Earth, and this one contains about 100,000 stars. It doesn't look as big and as populated as the couple of pictures I just showed you, but the distance is so much further away. 14,300 light years in distance. The globular cluster in Coma Berenice. This is a very popular star cluster, one of the most famous, M53 or Messier 53, 500,000 stars, about 12.67 million years, so it's very, very young. Remember, the sun's 4.3 billion years old, and some of these other star clusters are 11 to 12 billion years. This one's only 12 million years old. Very young, a lot of blue stars. But this distance is way away from 58,000 light years from Earth. This is actually almost kind of like midway between the center and the edge of the Milky Way galaxy. So very impressive looking star cluster here. The most famous of all star clusters is the cluster in Hercules, M13. And this has about 300,000 stars. It's about 11.65 billion years in age, quite old, many yellow and gold stars, about 25,100 light years from Earth. Well, another spectacular views from the telescope, of course, is galaxies. Now, a galaxy is a gravitationally bound entity, typically consisting of dark matter, gas, dust, and stars. Galaxies populate the universe, many residing in clusters and in groups. There are thought to be over 100 billion galaxies observable in the universe. Let me say that again. There are thought to be over 100 billion galaxies observable in the universe. Now, the Milky Way is our galaxy, and it's our home. We live on the outer edge of the Milky Way galaxy. The Milky Way is best seen in the summer months in the constellation Sagittarius. If you look south and then look upward, you can see the cluster of stars. There's so many stars that it appears in milky color. That milky color is not dust, those are actually stars off in the background. Number of stars in our galaxy, about 250 billion, or 250 billion stars in our galaxy. And interesting note here, all stars, nebula, and globular clusters that we can see in the nighttime sky except one, every one of them are contained within the Milky Way galaxy. The only object that we can see in the nighttime sky that is with our eyes that are not contained in the Milky Way galaxy is this one here. This is the Andromeda galaxy. It is our closest neighbor, galactic neighbor. It's about 2 million light years away, and it contains about 1 trillion stars. We're part of the Andromeda family. There's other galaxies, this one right over here. There's one way off in the picture you can't see called M33. And the Milky Way are all part of a family that are rotating around the same center of gravity. And eventually someday the Milky Way galaxy and this galaxy here, the Andromeda galaxy, will merge to form a mega galaxy. Kind of similar to what's going on over here. This is a distant galaxy about 23 million light years away called the Whirlpool galaxy. This galaxy here contains about 100 billion stars, so it's smaller than the Milky Way. But then here's a companion galaxy here that's being absorbed by this huge galaxy here. This little smaller galaxy contains about 20 billion stars. This one is nicknamed the Black Eye galaxy because it looks like it's got a black eye right here. And it contains about 100 million stars. Let's check that again, 100 billion stars. I put this in numbers so you could see, instead of writing down the millions and billions, here you got the hundreds, the thousand, the million, and the billions here. And it's about 24 million light years from Earth. All right. Two galaxies side by side up in the sky. You can see these with a small telescope. Again, they're not going to look like this. They're going to look like fuzzy little lights in the sky. You got the Cigar Galaxy here and the Bulge Galaxy here. This is M81, M82, and this one here contains about the same as our Milky Way galaxy, about 250 billion stars. M82 about 30 billion stars. But M82 is an extremely interesting galaxy. I'm going to show you a closer view of this. This is about a 2-hour exposure, 2.5-hour exposure, and it has about 30 billion stars in it. But this area here in the core that's perpendicular to the shape of the galaxy itself, we're looking at this very basically edge on. It is showing an exceptionally high rate of new star formation. So, you know, when you read in Genesis, God created the heavens and earth and he rested on the seventh day. Well, I don't know if the seventh day is really here yet because new star creation is going on. The creation is still ongoing right now. These are new stars being born in this galaxy right here. And it's about 11.5 million light years from Earth. And you know, there it is, 2 hours and 10-minute exposure just to get this picture. Okay, here's a edge-on galaxy. You're kind of looking at it edge-on, and this is called the Silver Sliver Galaxy, edge-on view, about 500 billion stars, so it's twice as big as the Milky Way, about 30 million light years from Earth. Here's a pinwheel-type galaxy. You're looking at it face-on, so you're looking directly down on it, let's say, or directly up at it. And it's also known as the Little Pinwheel Galaxy, and it's about 40 million light years from Earth. And it contains about 250 billion stars. Again, very similar to what we expect the number of stars in our own Milky Way galaxy. Now here's the Big Pinwheel Galaxy, or just known as the Pinwheel Galaxy, Messier number 101. This is a 1 hour and 8-minute exposure back in April 2018. This is a big galaxy. Like the Andromeda galaxy has about 1 trillion stars. And it's about 22 million light years from Earth. It just boggles my mind at how many galaxies are out there with billions and trillions of stars per galaxy. Here's two galaxies that are colliding. These are called, nicknamed the Siamese twins, sometimes also known as the Butterfly Galaxy. These galaxies are in the process of colliding and merging with each other, with the high star formation occurring right where the merger is ongoing, right in this area here where they overlap. This one is way out there, 59.4 million light years from Earth. So you do not see this in a small telescope through the eyepiece. You got to do a time-lapse photography to get a picture like this. This is a couple hours of exposure time. The Sunflower Galaxy, well, you know, I had to get some sort of flower in there since I had the Heavenly Backyard Garden and the Heavenly Backyard Astronomy. This fits both of the categories. The Sunflower Galaxy kind of looks like a sunflower. Also, if you notice, these galaxies all look like hurricanes, very similar. Number of stars, about 400 billion, so it's a little bit bigger than our Milky Way galaxy. And it's about 37 million light years from the Earth. All right, this is the, if you ever watched the old episodes of Outer Limits back in the 1960s, I think it came out, or maybe 70s, early 70s, they used this galaxy as one of their backgrounds. But this is the Sombrero Galaxy because it looks like a Mexican hat, a Mexican sombrero. It's got about 100 billion stars in it. This is prominent and low in the southern sky in early summer. So it's very hard to capture because you're looking through a lot of atmosphere and you're getting a lot of atmospheric aberration going on trying to photograph this. But this is about 30 million light years from Earth. Here's a triplet of galaxy, or some people call it the Leo triplet or the triplet in Leo. This is a 1 hour and 37 and 30-second exposure. I used a little 3-inch telescope. You don't have to have a really big telescope to see a lot of these things. You just have to have a good camera and patience and processing techniques. But there you have M65, which is about 36 million light years away, about 200 billion stars, number of stars, M66. Another spiral galaxy about 25 million light years away, about 200 billion stars. And then this one over here is called the New General Catalog 3628, or nicknamed the Hamburger Galaxy, and it's about 35 million light years away. This is a very interesting galaxy. I plan to do some close-up views of this in the future astrophotography nights. When you're speaking of galaxies, they even come in clusters. I mean, this one boggles my mind. When you look at this, there are so many galaxies. There's one there, and one there, one there. There's some back there, one there, and another one here, one here. They're all over the place. This is a cluster of galaxy in Virgo, and this is only a segment of the picture. If you can get a really, really wide view, you would see so many more. And if I expose it for a much longer time, a lot of these far distant galaxies, like that one right there, would show up even better. Anyway, this is called the Galaxy Cluster in Virgo. The giant 2000 galaxy conglomerate is about 65 million light years away from us. So I took this again with the little ED80 telescope. Again, you don't need a big telescope to get some big pictures. So besides the galaxies, we got the moon, and last January in 2019 we had the lunar eclipse that was total here in Savannah, and here we are in the heavenly backyard garden in the autumn time, actually winter time for me, and there's the telescope I used, and I used the Canon camera attached to the telescope on this particular night. I wanted to use the Canon. And this is the pictures of the total lunar eclipse, and there you can see as the moon went from full to partial to total eclipse, and then out of the eclipse back to full. During the full phase, this picture here, or the first one down here but underneath my picture, that was about 1/2000th of an exposure time, 1/2000th of a second exposure time. But as the moon was being eclipsed, the light was getting dimmer, and so the exposure time was getting less. This was about 1/500th of a second. And then as it went into the nearly total portion of the shadow of the Earth casting on the moon, the exposure time for this was down to about 1/20th of a second. This was down to about 1/8 of a second. This was down to about 1/4 of a second, and when it was at its total phase, and then coming back out. So I was writing the exposure times on the camera, and I put this together as a conglomerate of the all the different exposures I took that night of the eclipse of the moon. This was when it was at totality, and the interesting aspect about this is that since it was only 1/4 of a second exposure, I was able to see the background stars along with the moon. When you take a picture of the full moon, it's so bright, and like I say, 1/2000th of a second, you're not going to see many stars at all. But at 1/4 of a second, you're going to start seeing stars, and that's indeed what I had here. So when you're talking about telescope, and you want to maybe get your own telescope or rent one or have a friend with one, what is needed? That's the question here. Okay, number one, there are different types of telescopes. You have refractor telescopes, reflector telescopes. This is kind of like a reflector telescope, but it's called a Maksoutov-Newtonian telescope. The big one I had, the 11-inch, that's a Schmidt-Cassegrain telescope. On this one, the at the Maksoutov, you have the mirror is down in here. You have a corrector lens right on here, and attached to the corrector lens you have a secondary mirror which is back behind in here, and that reflects the image back up into the camera. So the light comes in through this lens in here, which is capped at the moment, but then it is focused and it goes down to the mirror, which is parabolic in focus, and then that reflects back up here into the secondary mirror, which is at 45-degree angle, and reflects back up into the camera itself for the exposure. And again, everything is up on a equatorial mount. There's another type of telescope you can use called the Dopsolian. Also, you can use binoculars. Guide scope. This is a small telescope with a small camera on the back side of it, which you connect into your computer. It helps guide the scope if the tracking is not exactly perfect with the equatorial mount. It will tell the mount to get back on track, basically. So you keep a good tracking, which is needed if you're going to do 2-3 hour exposures. The equatorial mount with an electronic auto tracking go-to system is probably the most expensive and the most important portion of astrophotography. For just a visual telescope, you can get away with sitting on a tripod, but if you're going to be tracking the heavens, doing astrophotography, you're going to need a good equatorial mount. And in several cases, the mount could actually cost more than the telescope itself. The camera, you can use a DSLR. The Canon is excellent, the T2i or the T7i, which is up there, or T3is. All those EOS cameras are very good. You can use Nikons as well, but it seems like the astrophotography world uses a lot of the Canon cameras. Or you can use a CCD or CMOS camera, dedicated astrophotography camera. That's what this one is right here. And this one is electronically cooled, so I can cool it down to very low temperatures, which gives you a better black background picture instead of a lot of electronic noise that you get with electronic cameras. And a portable computer, that's very important. Or if you are like me, I have all this connected to my desktop computers via long extension cables. And then you need good tracking software. PhD guiding is very, very good. Imaging capture software. A lot of times these cameras, when you buy a camera, you'll get the imaging software or links to other software that you can purchase for a moderate price, not very expensive. And then the imaging processing software, that could be a little bit on the expensive side. There's two that I use a lot. Photoshop CC, which is very, very good. It's not cheap, but it's worth it. And another thing called PixInsight, which is a dedicated astrophotography processing tool to help with the producing of the pictures itself. So anyway, that's my program, and that's the website, Pat Prokop's Weather and Nature page, and that's at www.savannahpat.name. So, well, thanks for watching, and unless you need rain, clear skies.